Alright guys, we're leaving the topic of series now behind and we return back to integration a little bit. If you look at this, at the timeline that we have, we did skip a few lectures, but we are well on time. We have 6 lectures left and I'm going to do 3 more days I'm going to spend on new material. The first topic is this one, and then the other topic, I'll do 2 lectures on that, is on volumes. Also, that's also an integration problem. And then the 3 last lecture are basically lectures where we're going to review things, do quizzes, and okay, so technically we're going to have a final, right? But don't panic now, don't freak out. Oh, final, what is it going to be? It's going to be just extended quizzes, okay? Quizzes, more questions during the last week. We're going to do this various quizzes if you want, but it's your final, okay? And it's going to be, of course, material now from the whole course, but we will review everything. Don't worry, I'll explain how we're going to do everything. Okay, so let's go to this particular topic now, area between 2 curves. And let me quickly remind you of what these integrals were, right? So we had a function, f of x, say, f of x. And then what was an integral? Well, you had a certain region from a to b, an interval, and then you would want to calculate the area underneath this curve. And that area we set, or we defined if you want, to be this integral here, fx dx, the definite integral. Okay, that's quite familiar to you, right? But what is kind of unsatisfactory is that these are very artificial domains, right? Okay, have you ever seen something, a picture that looks like this, right? Okay, the top is nice, it's curved, and it's like a, but then the other axes are just straight. You wanna take the areas you're thinking about, circles or something like that. I would like to find the area of something like that, right? Now that might be a little bit too complicated. This is what I just drew here, but we're going to do a slightly nicer things. And so what we want to do is, let me get rid of this picture, is this following situation. So now we're going to not have one curve. So this is one curve, say f of x, but there's going to be a second one. And for simplicity, I'm first going to draw them a little bit apart. Sorry, that's not really a curve, right? Something like that. I don't mean to say anything particular here. So let's call this curve g of x. So we have now 2 equations. And we're going to still have a domain, a to b, say. So what are we interested in? Well, the region, look at the area between 2 curves. You can guess what it is. We would like to know what is this on this interval. So we're still working on intervals, so it's still a little bit unsatisfactory that we have these straight parts here, but bear with me, we're going to get rid of this somehow too. Okay, so now this is what we want to find. I don't want to explain too much about it, I'm just going to give you the formula. It's rather easy. Let's think about what should we do here. Sorry, I apologize. I'm going to make a slight adjustment to make it, it's going to make it easier for me to explain things here. So I'm going to actually move my x-axis a little bit lower. I want everything above here. Remember, when we say this is an area, integrals are areas, then we should say area with sign, right? It's positive if it's above the x-axis, but it's negative if it's below the x-axis. So I don't want to run into this issue now, so I'm going to put my x-axis a little bit lower here. So this is my a and b, okay? Just to have a bit nicer picture. Okay. But in fact, what we will do today, we will actually not have to deal with this issue. You'll see, but that's for later. Okay, so here we are. Well, look, what is this black thing? It's actually geometrically, let's look at what is geometrically. Well, geometrically, let's fill up this part underneath of here, the blue one. What is the blue guy? Well, that's just the area underneath gx on the interval AB. So the blue guy is just AB gx dx, right? That's just the blue guy. Now the blue and the black together, what is that? So I'm going to make that blue and black, that's purple, no? So I'm going to make it a little bit purple. So what is this guy? The blue and the black together. Well, that's just the area underneath f of x. So the purple guy is just a b f x dx. So what is the black guy? Well, it's the purple guy minus the blue guy, right? So let's subtract these things, and that's what we want. That's the area that we're looking. The big area minus the small area. Good. But we have a property of definite integrals is that we can combine them if they are in the same domain, same range here, same endpoints, then we can write this integral just as f minus g dx. And that's it. So the area between two curves is given by this formula. Very simple formula. There's one thing though we have to be careful about. You see there's a minus sign, and when you have minus signs, it always matters whether this... How do I get rid of this? I don't know what this thing is. Okay. When you have a minus sign, there's always the order is important, right? So why f minus g and not g minus f? Well, it's clear from the picture, right? F is the top curve and g is the bottom curve. Now, there are many ways that we can establish this. One is to make a picture and look at the picture and see, oh, f is on top, g is on the bottom. Okay? So, but suppose you get something like this here. Here is a question, typical question. So find the area on the interval from, I'm going to take 0 to 2, between the two curves. I'm going to give just equations. Y equals ex and y equals 8 minus x squared. They are both curves, right? So but the question now is, where are we? And so we need a picture for this thing. And so to see what is top and bottom. So first, so on the picture, let's do that first. The picture is going to be a sketch, right? Ex looks something like this. It goes to 1 here. So this is ex. And 8 minus x squared is a parabola, but the negative sign, it means a parabola pointing downwards. Its y-intercept is 8, so 8, and it looks something like that. Very, very, very roughly. And 0, of course, is here, whereas 2, well, e square is... oh, sorry, 8, I made a mistake, sorry, I meant 9. No, let me be, I want to make sure that I don't get this here. I'm going to take 10 here, sorry about that. Because what I want is to make sure that they don't cross on this interval. And you see from this picture on this interval, so 2 is somewhere here. So 2 is somewhere here, so we're talking about this area here. Okay, so this curve is 10 minus x squared. So which one is the top one now? Well, you see on the picture, it's 10 minus x squared. Okay, so this in the formula comes first, and then the other one comes second, because for subtracting, it's important. Now, if you don't want to rely on a picture, you can also make a table. And so this is something that we're going to do shortly, so I'm going to explain it now. So we have the two equations, ex and 10 minus x squared. And now we have to assume that they don't try to trick us, and that one is on top and one is at the bottom. Okay, we could have this situation, right? So, okay, let me point out. Something that we have to deal with, but not yet, is something like this. Suppose we have something like this. If these two curves start intersecting, and we have to go on this interval here, then it gets a little bit tricky, right? Because sometimes f is on top, if this is f, and then sometimes g is on top. So when they cross, it gets more complicated. But that's for later, okay? So now I'm assuming that doesn't happen. Well, they cross, but not on the interval, right? You see the crossing is outside my interval. So assuming that this is true, I can figure out which one is top and which is on bottom by using just a test point. So here I'm going to put a test point. So this is a test point. What is a test point? Well, any number inside this interval will work, but inside. So let's take 1, okay, test point x equals 1. So this is inside the interval 0, 2. But if you want to take 1.7, be my guest. Okay, so what happens? If I plug in 1, I get e, and if I get 1 here, I get 9. And now, what's the top one? It's the one that has the highest value. This 9 is clearly bigger than E, right? E is 2 point something, okay? So this is the top one. And that's without really meaning a picture, we see already what it is. So now we can write down the formula correctly. So this integral, this area, is equal to, well, the endpoints are given, 0, 2. The top one is this guy, so 10 minus x squared. We subtract the bottom guy, minus ex. It's subtracting, right? dx. And now this is now it becomes the integration, right? So this is an easy integral, but you could have more complicated integrals. But let's do this one quickly. Integral 10x minus x cubed over 3, and then minus the derivative of ex is just ex, and this is between 0 and 2. So we have plug in, that is 20 minus 8/3 minus e squared, minus, now plug in 0, that is 0 minus 1. Be careful, e to the 0 is 1. And that's it. You don't need to simplify. But as long as you plug in the numbers, you can show me what they are. If it's really nice small numbers or something, combine them, but you see there's a fraction, there's an e squared here, it's not going to work. You cannot really combine them. Okay, that's it. That's it. That's, as I said, still a little bit unsatisfactory because these kind of regions, okay, now you have a bit curvature there, but it's still straight here and here, right? So what, for instance, look at this picture here. What we would really like to do is some shapes like this, where we have a bottom curve and a top curve and they intersect each other. Okay, now this particular question is going to be difficult because what's the problem here? Well, now we don't give, well, if I tell you where they intersect, then you're fine. But if I don't tell you, you need to find out yourself. So let me do this on an example. It will become more clear. So let's take the example. So find the area between. So find area between y equals 9 minus x squared over 4 and y equals 6 minus x. Okay? Now notice there's no interval anymore, right? The difference of the question, find the area on the interval between these two curves. Here we are just given two curves. So find the area. So what is more, the way that it's normally formulated, so I'm going to formulate it slightly better, is find the area bounded by these two equations. Now we can make a picture of this, and then with the picture we see what is going on. And well, it's not so hard, right? Because one is a parabola, and again, because the negative means it's a pointing down parabola, and the other one is a line. So the picture is something like this. The book has a better picture, I'm not gonna. So what is now find the area bounded by of these two things. What does it mean? Well, that's the area we're talking about, right? This is the area that is bounded by these two curves. This here is not bounded by the curves because it goes on forever. It's an unbounded part. So it's the bounded part when we say bounded by, okay? Good, that is good, except now, as I said, the difference is here we are given interval, here we are not. But we need an interval, right? Because we need the endpoints. So what we need to do is find these intersection points. So step 1, what are the intersection points? Now think about it. How do you find intersection points? Okay, try to answer this before you go on. What you need to do is find what is the intersection point? That is a point that lies on both of these curves. That means that satisfies both equations. So we have to put one equation equal to the other. So 9 minus x squared over 4 equals 6 minus x. So you put the two equations equal to each other and solve for x. Now let's do this out. So I don't like the 4, so I'm going to multiply everything with 4. 36 minus x squared is a 24 minus 4x. It's a quadratic, so everything goes on one side. Bring everything to the right hand side. Okay, so I'm going to do, well, okay, I hope you can see how to do this, right? So that is 0 equals 24 minus 36 minus 4x plus x squared. So that is, I'm going to now write the usual way we write our highest degrees first, right? X squared minus 4x, and that is minus 12. So I need two numbers that multiply to negative 12 and add up to negative 6. I think negative 6 and plus 2 do the job, right? Yes, okay. So this we put equal to 0 and we find the solutions by the zero product property. Each of these terms might be equal to 0, so x minus 6 equal to 0 means that x is 6 and the other one is x is negative 2. So we get two intersection points, and this is as the picture shows. Now sometimes of course you could have more intersection points, and then we are exactly in the situation where we have several intersections here. You see, this can happen too. Okay, we will do an example later. So that we have the intersection points. Now the issue is still about which is the top and which is the bottom. We can make a picture, we can have a graphing calculator and we can put it there, or you can use an online tool. But I want to do it still algebraically, and so I'm going to resort to the same method that I used here using this table. So I'm just going to step 2, the table. So, and on the quiz, I want you to do it this way. Okay, you can use other means to figure out how things look, but I need to see all these steps here. So what's the table? What do I mean with that? Well, it's simple. You take the two equations, 9 minus x squared over 4 and 6 minus x. Now, what is our interval? We have negative 2 and 6, right? I put the endpoints of the interval because I need to find a test point in between. Okay, so the test value, whatever you call it, has to be somewhere in between here. I guess everybody wants to choose 0. That's the easiest one if you can, right? But so in order to find the test point, it's important, therefore, that they're listed in the right order. So don't put 6 first and then negative 2, although you found 6 perhaps the first. It's the order in which they come, right? It's like we're making a line here, the x-axis. I mean. Okay, so we plug in 0, and what do you get? 9 and 6. What's the top? Well, the biggest one. So this is the top curve. So now we can write down the integral. So step 3, the actual area. It's the integral from what? Well, the endpoints, we found them now. Negative 2, 6, again in the correct order. You take the biggest one, the top curve, this was the top curve, and subtract from that the bottom curve. Be careful with the subtraction that you don't mess with the negative signs here. So we have to integrate this guy, so let's integrate this. So there's the integral from minus 2 to 6. 9 minus x squared over 4 minus 6 plus x dx. I can combine the 9 and the minus 6 into 3. Can I do this on the spot here? So, okay, so we get a 3 here. And now I enter derive. That is 3x minus x cubed divided by 3, but I have also 4, so actually the whole thing is divided by 12, plus x squared over 2. Okay? And that is between negative 2 and 6. So now we can plug this in. That is 18 minus, well, that's a big number. I'm kind of lost interest in actually the number here. Although you see it actually comes out. And minus, so this is minus. Now we plug in negative 2. That's minus 6. Minus 2 to the power 2, that's minus 8. But we have already a minus, so 8 twelfths plus 4 halves. Okay. And we can simplify this. I think I'm going to still have a fraction there. I don't know. I'm not going to do it. Let's not do it. Whatever this number is. The example is actually taken from the book, so you can look at the actual answer. Okay, so you see it's rather easy, right? Well, rather easy. Of course, it is sometimes a problem to find intersection points. Finding solution of equations is actually very difficult in spite of the fact that we're constantly doing it. But it's because we always take very simple equations, that's why. It's an easy topic, that's what I'm saying, so I'm going to do a quiz on it, so everybody should get a high grade on the quiz, especially if you don't make mistakes here, right? But there's one complication that I'm going to do is, we have to still discuss this case, what happens if curves intersect themselves several times? Okay, and so let's look at an example here. The curves I do, so again, so find area bound of region, that they normally put the word region here, of region bounded by the following two curves, y equals x cubed plus 2x plus 1, and y equals 3x squared plus 2x plus 1. Okay. Now, this is already a bit third degree equations. You sometimes want to make a picture. So let me see whether I can get you a picture here. I have to go to use Wolfram Alpha. So I'll show you, or you can see this. You can of course use your graphing calculator, but it's harder for me to show a graphing calculator, so I do rather Alpha. So we do graph or plot or something at y equals what was it, x cube plus 2x plus 1 and y equals 3x squared plus 2x plus 1. Okay, let's see what we get. So you see here the two curves. Now, you see, this is different resolutions, right? On this resolution here, you have a hard time seeing what happens, the first one, okay? But in the second one, this is what I'm trying to say is this first plot is too close up, and we don't really see. It looks like they're touching, but if you really look at a bit larger outlook, you see that the values, the y values are much bigger here. You do see that they kind of intersect each other here. There is something going on here that we can still not see here. So in this part, we might want to enlarge here. I don't know whether this works. I'll zoom. Oh, that you need to go pro for this one. Okay. You can do this better on a graphing calculator. And so what you would see is that the picture is something like that. So let me go back to my note. So it's something like one curve is this and the other one is kind of doing this. So you get like two regions cut out. The problem is exactly, that's the reason that I insist to doing things with tables and not just by picture, is because pictures are very hard sometimes. Because you need to really zoom, you have the right zoom settings to see what happens, and sometimes you cannot see everything in one picture. That's the problem. So what is going on is something like this, but it's hard to see. Okay, trust me. So therefore, but we don't have to worry about that. Let's do this whole thing algebraically in the steps that are just described. So, okay, step 1. What are the intersection points? Remember, this was putting the two equations equal to each other. X cubed plus 2x plus 1 equals 3x squared plus 2x plus 1. Bring everything on one side. X cubed minus 3x squared plus 2x minus 2x, so these two x's actually cancel, these ones cancel. Okay, so this is actually that. Oh, great. So we get x squared, x minus 3. And, sorry, yes. Oh, I'm sorry, this is the wrong example. It is an example I wanted to do, but the picture here is, I miss. If you go back to the picture, let's go back quickly to the picture here. What you see is that it touches here, and we get something of the picture. It's a bit hard to see on the picture here. Sorry, I had to do two examples, and I did them in the wrong order. This example is actually something where we have one curve, and the other curve comes to it, and then touches it and makes this, stays above it. So we don't know exactly what is what, so let's work this out. Well, we put this equal to 0, the two possibilities. X is 0. Don't forget that this equal to 0 means x squared equals 0, but that square equals 0 means that the number is 0, and this means that x is 3. Okay, so what is step 2? What's the top, what's the bottom? So we make the table. We have the two equations. Let me give myself a bit more space here. What are the two equations? X cubed plus 2x plus 1 and 3x squared plus 2x plus 1, and we have 0 and 3. So we need a test point. it has to be in between, so for instance 1. I get 1 plus 2 plus 1, that is 4. And this one is 3 plus 2 plus, this is so ugly, oh, there's a plus 1 there, right? So 3 plus, yeah, that's 6. So this is the top curve, so the step 3 are area is the integral from 0 to 3. The top curves first, so 3x squared plus 2x plus 1, and subtract from that, sorry, that's a plus 1 there, right? You can see it. Subtract from that the other guy, x cubed plus 2x plus 1 dx. Let's work this out. We have a 3x squared, we have a 2x, but they cancel with the negative 2x here, and that 1 cancels with the 1 there. Okay, so if you cancel this out, do it separately if you don't believe me, and you get this. Okay, so and to derive this, that is x cubed over 3x cubed over 3, so that's x cubed, right? Minus x to the 4th over 4 over 4, add 1 to the exponent, divide by it, between 0 and 3. So that would be 27 minus 81 over 4 minus 0, and that's the answer. Again, no need to simplify anything. Okay, so I want to do one more. Let's do this one. Sorry, give me a little time here to do this. Let's do okay, so I want to do the following two ones. So same question. Y equals x cubed minus 14x plus 5 plus x squared, sorry, I write it in a bit awkward way, and y equals, where is it, x squared minus 14x plus 5. No, I'm sorry, I got a little bit confused here. Give me a sec, guys. Okay, this is, do this. Okay, sorry. It's plus 2x plus 5. Okay, and so let me rewrite this one a bit better here. So I mean here minus 14x plus 5. So sorry. So x cubed plus x squared. Okay, so that's the second one here. Okay, so these two here. So step one, again, sorry, yeah, so this is now a picture, but I'm not going to make the picture, but this is a case where we have something like that. Two curves keeps intersecting, so we get these two different regions. So perhaps we could have more regions, right? In this particular one, we'd have even 3 regions, but we'll see. How many regions do we have? Well, we figured it out. So what do we do? We put it, so the intersection points. So x cubed plus x squared minus 14x plus 5 equals x squared plus 2x plus 5. Bring everything to one side, the 5's cancel, so I have an x cubed, the x squared is also cancel, and then I have a minus 16x, so I factor it out as x times x squared minus 16, correct? Okay, don't forget to factor out an x. Right, because if you can factor it out, right? So now this is difference of squares, or if you just want, it's x minus 4 times x plus 4. So what are the intersection points? Now, very important. Sometimes people ignore the fact that there's an x here. Cannot be ignored. It means x equals 0 is a possibility. So x is 0. This is x is 4, and this is x is negative 4. Okay. As a rule, when you have degree 3 here, there's a degree equation, you should 3 solutions. Now, what happened in the previous case was that we had a solution that counted twice this x squared here. We talked about these kind of things, about multiplicity when we're doing integration by parts, partial fractions, right? So this can happen, and so, but in general it doesn't happen here, and we have really 3 different intersection points. So step 2, the table. Okay, but what has to go in the table now? So now you have to pay a bit attention. What happens if you have more than 2 intersection points? Well, let's put them all there in order. So negative 4 has to come first, then 0, and then 4. So we're going to have, what is going to happen in general, so the picture, and one more time, it will be something like this, right? exaggerate a little bit. So at some point, one of the curves is on top, and another point, the other one is. So what we're going to have to do is split the integral in over, we have this integral we're going to do, and then also this integral. And how do you know what is on top and bottom? Well, we have the intervals here, and so we have also the two equations, that is x cubed plus x squared minus 14x plus 5, and the other one is x squared plus 2x plus 5. And now we need to find not just one test point, but a test point in each interval, because what is going to be the case, that's for sure, that whenever we are between two intersections, so if we are in between two of these intersections here, the one curve is always going to be on top, the other is in the bottom. They cannot switch roles, because switching roles implies that they have to cut, right? This is called the intermediate value theorem from Calc 1. So they have to, one is always on top, one is on the bottom. Which one it is? Well, take a test point, take -1 here. But this only tells me it's for this interval, so I need to also know this interval, so I need another test point, take 1 here, or 2, or whatever you want to take. Yeah, just so that, to show you that you can take other numbers, let me put 2 here. So these are test points that you choose yourself, as long as they are in the right intervals. Okay, let's plug in -1 in the first one. So this one, we get -1 plus 1 plus 14 plus 5, right? And if I plug it in -1 here, I get 1 minus 2 plus 5. Let's see, that is 19, 20, that is 19. And this one is 6, 4. So clearly this one is the top. But notice now what happens if I look at 2, say. Well, I said we can take 2, but now I'm getting chickening out, because it's kind of a little bit of calculation then. So let's do just 1. So 1 plus 1 minus 14 plus 5. And here I get 1 plus 2 plus 5. This is 7, 8. And this is equal to minus 7. So now, of course, the positive one is the bigger one. So this is the bigger one. So what does this mean? This means that we're going to have to split this integral. So let's work it out now. So step 3, and this is the last thing now. I want a blank. So step 3, we write down the integral, the area. And as I said, we split everything in each interval, from -4 to 0, and then we have another integral from 0 to 4. It's the endpoints, right? Now these test points, -1 and 1, do not play any role anymore, right? Don't get confused by them. So what does now go here? What do I have to write here? Well, here I have to write the top one first. So this was the top curve and this interval. So we have to do x cubed plus x squared minus 14x plus 5, and subtract from that the bottom curve, x squared plus 2x plus 5 dx, just plays enough. But here the next one, the roles are reversed. Now this is the top one, so I'm going to have to write this one now first, x squared plus 2x plus 5, and then subtract the other guy, minus x cubed plus x squared minus 14x plus 5 dx. Okay? Now you say, oh my god, there's a lot of integrals, but not really, right? Because let's look at this, what happens here. X cubed, we have a term, the x squares cancel here because we're subtracting, right? And the 5's also cancel. So we have x cubed minus 14x minus 2x, so x cubed minus 16x dx. Okay, I hope, do this more slowly if you didn't see what I'm doing, right? And convince yourself that this is the correct answer. What do we have here? Well, same thing, the x squares cancel and the 5 cancel, so I have 2x, I have 2x minus x cubed minus so plus 14x dx. Oh, but I can combine the 2x and the 14x, so this becomes 16x, okay? And notice how they look similar, except one is negative the other. No surprise, right? Because in the one we took one curve minus the other, and then in the other one we did the other way around. The only difference is it's a sign. So that's why you can see that if you make a mistake, if they're not the same up to sign, then something was somehow wrong, right? Okay, now, final step, of course, we have to integrate. That is x to the 4th over 4 minus 16, so minus x squared, right? 16x squared divided by 2. That's between -4 and 0 plus, And now we have minus x to the fourth over 4 plus 8x squared between 0 and 4. And let's plug it everything in. So we plug in a 0 there, and then minus, and now we plug negative 4. Negative 4 to the power 4 divided by 4, that actually is negative, it's a negative 4. If you take the fourth power, that's a positive number, right? So now a fourth power of 4 divided by 1/4, that's actually the third power of 4, that's 64. Minus, and then here I get 16 times 8, that is 128. Right? Okay. Plus, now I'm plugging 4. I get minus 64 again, right? The number is again the same. Plus 16 times 8 is 128. So what I get is, be careful with all the negative signs, I get negative 64 twice, so I get minus 128, and I get plus 182 twice, so plus 256, so the whole thing is just 128. Again, that's not necessary. But my point, the reason that I wanted to work it out is to show that this is actually positive. And this is another thing. This number is by construction always positive. Because we took always the smallest, because we made sure that we subtracted the bigger from the smaller, the result is always a positive number. Okay? So that's also when you can test whether you made a mistake or not, if that's not the case. All right, so that's it. And so what happens when you have multiple points, if you have three intersection points, or suppose you have 4 intersection points, so you would have something like this, a couple of times, so you would have 1, 2, 3, 4. That means actually you look at the number of intersection points would be actually 5 intersection points, right? That can happen, and then you take these 5 intersection points, and between each 2 of them you have an interval, and you figure out which is top, which is bottom. Now you cannot just assume that it switches all the time, because you could have pictures like this, right? You could have something like this. You could have one coming and then actually not going through, and now it goes through. Okay, so we have some pictures like this tells you that you cannot just expect everything. Like sorry, I meant actually to say this here. So suppose this happens. You say this is on top. The next time it's still on top, and it's only the third time it goes on below. Anything can happen, and therefore you should not rely on pictures or on guessing. You have to make the table. This is the only way to really be sure that you have the right one on top. And then if you have everything right, the answer should be positive. Okay, so I'm going to assign some homework problems, and then we do a review next time for a quiz.